Welcome back to the morning show. It's our favorite time of year, or actually favorite day of the week, Wise Guy Wednesday. And one of the best things about this time of year is the crystals when the frost forms on the window. And I've always wondered how that happens. And that's Salem is here to tell us.
I was looking forward to that today. But it's raining, Robert. What's going on?
Wait a bit. We're getting one last gasp of mild air, and then it'll cool down this afternoon. And we'll have to maybe see some crystals, and you're going to tell us how these things form.
That's right. That's right. So we've been doing all these big electrical things, and so I thought we'd switch to something smaller and talk about crystals.
Okay.
And a crystal is a special kind of solid, and I don't know, maybe a month or so ago, we talked about solids, liquids, and gases, and we played with liquid nitrogen, you might remember.
Oh, yeah.
And so the difference being that in gases, the molecules don't touch and they bounce around a lot. In liquids, the molecules are touching, but they sort of slip around on each other. And in a solid, they're stuck together. And a crystal is a special kind of a solid where the molecules are stuck together in a very regular way. And so here's sort of a ball and stick model of salt, actually. You can make a crystal like this at home. And I'll put a recipe on the website tonight. But this is basically sodium chloride. And you see, if you cool liquids, or if you have a saturated solution of sodium chloride and you let it form very carefully, the atoms arrange themselves in a very natural cubic fashion. This is called a cubic crystal because each little piece of it looks like a box. Okay, and so there's a lot of things which have the same cubic symmetry. Pyrite or fool's gold is one of them, and if I pick this one up, you'll see that, and this is a naturally occurring thing. It looks like little boxes.
They are that cubic when they're formed.
Yes, it was formed exactly like this, in a mine or underground someplace. Isn't that something?
When you brought that in, I said, "Wow, is that gold?" Yeah, that's fool's gold. So it tricked me.
Right, and so there's different kinds of symmetries. Cubic is one, and you can see these little cubes here. And what's amazing is that you start out with just a few atoms that form this cubic shape, and then as more and more atoms arrange themselves around the original ones, they retain the same shape all the way up till a macroscopic size that we can see, which has 10 to the 20 or some huge number of atoms in it. Another very common shape is called hexagonal. So here's one of those, and you can see the atoms arrange themselves in a sort of a six-sided shape. And I'm bringing this up because this is the shape that water freezes into if it freezes very carefully. It's also the shape of quartz. And so, for example, here's a piece of quartz. This is a single crystal of silicon dioxide quartz, and you can see that it has 6 sides. And here's one that's a little more naturally occurring that we were looking at before. It's quite beautiful. And so this has the 6-sided symmetry, and it's the same sort of symmetry that we see in water. And in the next segment, we're going to talk about snowflakes, because the 6-sidedness,
this will explain why we have 6 spokes, basically.
Why we have 6 spokes, and we'll talk about why all the spokes are the same and everything else.
Okay, looking forward to that. I'm going to learn a little bit more about the weather business this morning from the Wise Guy. We'll hear more from him in the next half hour. Still ahead on the morning show, we're going to be heading on a nice, relaxing retreat in today's Wish You Were Here postcard. Plus, do you